If you keep cutting a piece of paper in half and in half again, eventually you'll get to a point where you can't cut it anymore. But are we sure that's really the smallest unit? The answer starts with the atom. J.J. Thomson was experimenting with a new technology called the cathode ray tube. The device was made up of a glass tube and two metal chips connected to a battery. When Thomson turned the battery on, a ray would shoot from the metal chips. Curious to know more about this ray, Thomson added electrical charges and found that the ray would always bend towards a positive charge. This strange behavior alerted Thomson that the ray must carry negative particles. Those were electrons, the first ever subatomic particles discovered. In order to explain his discovery, Thomson pictured the atom as plum pudding, negatively charged plum electrons scattered through positive matter. However, it doesn't end with the electron. There are other particles smaller than the atom itself. Using radium, Rutherford fired a ray of radiation towards a sheet of gold foil. In line with Thomson's model, he expected the radiation to mostly pass through. The results were startling. Rutherford was finding that on rare occasions the radiation would bounce back, as if hitting densely packed cores somewhere in the atoms. Those cores were the nucleus. So that's it? Electrons, the nucleus, the smallest cuts of paper? No. Over the past 100 years, scientists have used particle accelerators to smash atoms together. Here we found quarks, even smaller particles, and bosons, these particles that carry fundamental forces. Over the years, we've developed this into the standard model, a sort of periodic table for the basic units of matter. If we were not humans who dared to cut deeper, even in the invisible, then we'd be done. But there are still mysteries lingering around us, and we will uncover them.